Hey everyone, it's Simon. I wanted to share a quick video about the Draw.io MCP server for Azure. Oftentimes when you generate a diagram, perhaps a technical architecture diagram, you may open Visio or Draw.io, or you might create it from markup in PlantUML or Mermaid or any of the other tools that are out there. But what I found really a bit challenging was that I spent too much time creating these diagrams myself, or in the tools that I liked, there may not have been any Azure stencils available to me. So I set out to clone an existing Draw.io MCP server. I found a repository on GitHub that had 700 plus Azure icons on it. And once I combined that and I paired that with an extension in Visual Studio Code, it really came together to then form this MCP Draw.io server that I now have out on GitHub. And I'll share that URL in just a little bit. So what you have on my screen here is the Draw.io MCP server cloned project from GitHub on the left. And then on the right is just an empty Draw.io MCP test project. There are no files in here yet, and we're going to use this right one to fire off a prompt that we're going to send into the MCP server to then see if it can generate a diagram for us. What I need to do on the left here is start the MCP server. And this is going to run stdio locally as well as an HTTP server. For our purposes, I just want to focus on the HTTP server because that's also how I'm going to interact with it once it's out, maybe in Azure or elsewhere. So right away you can see that when it starts up, it is putting itself on port 8080. This is by design. It's a non-administrative port, so I can run it as a rootless user. It's setting up both transports for us, and then it has 25 MCP tools that it exposes. Also, we proactively load up the Azure icons that we have and make sure that we have search index for it. All of this uses a fuzzy search to help facilitate good matching. And then we have a little bit of warm up here so that the first request doesn't take any longer. If you have this behind load balancers, you're going to want to have a health check point here. And then you have the familiar MCP endpoint until the server starts. And all of this happened in about a course of a second or so for it to come up. So very, very fast. It's Deno based, so we're also focused on security here with opt-in permissions, and everything under the covers you can check out in the repo, the TypeScript aspects for it, all the tests that are in here, as well as the source SVGs for the icons and all of that you can find here. Okay, great. So now that that's running, what we need to do on the test site here is that we open up in our GitHub Copilot the Draw.io MCP JSON, and I already started this earlier. I already added it earlier. You can tell it's the same URL, locally non-secure. And importantly, it's using streamable HTTP, which is really the standard. And then let's just see what it looks like when we start it fresh. And as soon as I press this, you can tell that we initiate a request over to the server. And that now establishes that relationship. And as part of that relationship, the server sends its instructions down to the caller. And this is then everything that the LLM has at its disposal to understand how to interact with this MCP server. So in Markdown format, you can read it, I can read it, and the LLM can read it too. and then use it to make the best decisions on interacting with this MCP server without a whole lot of guessing. Goal here really was to make it very explicit and take a lot of the ambiguity out of it so that we don't have empty round trips or fails that we then have to prompt about or re-inquire about with the tool server. All right, so one item that I want to spend a little bit more time on is this Draw.io integration that we are using here. So Henning Dieterichs created this plugin for Visual Studio Code. You can tell it's massively popular, 3.5 million downloads. Everybody's happy. Yeah, 158 stars on this. And what's really, really cool about this is that it takes the XML format that represents the Draw.io diagrams and then visually shows it just like maybe the Draw.io website would do it inside of VS Code here. You can view it, manipulate it, whatever you want to do with it. For our purposes, it's really nice because we can quickly visualize what this diagram will look like. So find this out on the VS Code marketplace, give it a roll, and you too will be able to see Draw.io visualizations inside of Visual Studio Code. Okay, so no files in here yet. Let me widen this just a little bit so we can see this better. We already know that we started up our MCP server. Now we are using Claude Opus 4.6 for our prompt, and I'll fire it off and explain what exactly we're looking to do here. So we want an Azure diagram. We want front door as the point of entry. Behind that should be a container apps environment named workload A with two container apps named named web and API. Both of those container apps receive their images from a container registry named my registry, so we'll look for that later. And then we should also have a separate API named API2 that runs in an app service, and that is also directly accessible from front door. So sort of consider the container apps environment and the app service siblings here in the way that the diagram should be structured. And additionally, we want a whole lot of non-functional components added to this. It's really important that we show what we do for security, for identity, for telemetry, all of those components that you would typically have in a workload. We don't want to drop off a diagram. It should be represented somewhere there. Lastly, the public DNS that we are associating with front door is going to be workload-a.contoso.com. So somewhere in the diagram that should appear appropriately. The application, the LLM already knows, based on the instructions that we looked at, what it needs to do to interact with this MCP server. So the first thing, after it has derived its plan and created its to-dos, it knows it needs to start researching some shapes. And here you can see the front door, the container apps, app services, all the items that we talked about, as well as those directly non-functional related components that augment every workload. It fires all that off, and then the MCP server over here, in very quick turnaround, in 13 milliseconds, and with a payload of sub 4 kilobytes, then returns its search result for this, with information such as what the dimensions are, what category the icon falls into, what confidence we have in matching it. So you can tell, for instance, we have somewhere we're looking for app services, but really we may be finding app service plans in here, whatever it may be, and that returns various confidence, whereas the app services match here has a confidence of 1. So we're providing some options here to the LLM in order to select what it deems it wants to have. Then there's an additional search here the LLM had some follow-ups. It wanted to specifically look for container app instead of container apps. And then Microsoft Entra ID. Okay, no problem. Search shapes, 1 call would be ideal. 2 is not bad. And now that it knows everything about the shapes, it starts creating the group. So in here, we see that it then creates the container app environment group, and it gives it some initial dimensions for it that may or may not change once we start adding cells to that. And just down here, we then start creating a whole lot of cells. So every vertex, every label that we have then becomes a cell. And then we add certain cells such as the container apps environments. So here's cell 1 and cell 2, essentially. I'm sorry, a container app 1 and container app 2. We add that to the group ID cell 2. And we know that from the prior group creation that the container apps environment group was cell 2. So that creates that association for Azure Container Apps. Great. Now that that's done, there's some further cell editing, edge creation between them, make sure we have proper lines and whatnot. And then lastly, we call finish diagram, which rounds this whole thing out and then exports the diagram to us. I'll hop back over here on the server real quick, and you can just see how efficient this runs in that we have very, very minimal times that we spent on the server processing this, and we have relatively little payloads that go back and forth. And as part of these calls here, you notice that it says TXN, so we have transactions running, and that's a preference that we have provided in our instructions to say, hey, if you're creating a whole diagram, do it in a transaction manner so that we don't send the Azure icons, the SVGs, back and forth all the time. The server itself is stateless, and because it's stateless, we would have to transfer all of those icons back and forth, but instead, as part of a transaction, we just use placeholder boxes that are of the same size. And then in the finish diagram call later, we end up replacing those with the appropriate icons. And that's where you can tell you get the bigger payloads there in the end, because that now has the compressed XML that contains the SVG icons for it. Okay, super. Ran through a whole bunch of tool calling here. Looks like it's finished. It tells us the diagram has been saved to workload a.draw.io. Here's that file up there, so let's just see what it looks like. Okay, great. We got our front door that we asked for. Check on the point of entry. Then we have the 2 container apps named as part of the container apps environment named workload A. Okay, perfect. App 1 is named web. App 2 is named API. Check on that. Both container apps receive their images from the same container registry named my registry. So down here is my registry. I chose not to have edges going from these container apps to my registry right now. That's also evident in the instructions, things that can be tweaked. So if you clone this and you say, well, no, I want to do this a bit differently, I have added. Just update the instructions as to how you like to have diagrams created. Okay, we should have a separate API named API2 running in an app service. Check, that's down here. That's directly accessible from the front door, so you can see very clean edges running to the container app environment as well as the app service. And then the app service, because we're really in a parallel setup here after front door, they're vertically centered so that your app service isn't hanging out somewhere over here or somewhere far left. It's really done in a way that is supposed to be neat. We have various non-functional components in here. You see Azure Monitor, App Insights, Log Analytics for our observability and telemetry, Key Vaults for our secrets, Entra ID for our identity provider, and then some governing tools for Azure policy, as well as security, such as Defender for Cloud in here. All of this is very pertinent to workloads in Azure that we do nowadays. And yeah, so in a nutshell, this created our diagram. It saved it. You can check this into source control. You can have additional conversations with Copilot to say, hey, this is really nice, but can you now also add XYZ to it? And you can continuously iterate over this diagram that you have here. The idea is not perfection. I don't expect this to generate something for you that you immediately turn around and check in and save because it's just perfect and exactly the way you wanted it. But what I wanted to do with it is give you a really good head start so that you can create something that gives you a foundation for some hopefully just tweaks that you make after that. So hopefully you enjoyed this. I want to share the repo that we have for this, and that's going to be at https aka ms draw.io MCP server. So I have it right up in here in the browser, and that short URL will take you to my GitHub repo. You got the everything here that you've seen. You can also pull this image for the latest release that we have, which is release 3, just released an hour ago. Pull it straight from Docker Hub, run it locally, run it in your container registries. Whatever you want to do with it is just fine. You can tell it's a very small image that we have here. We run very minimal images for this with a Debian base on it, and it's running as a non-root user with everything stripped out that the image doesn't need, so you have a lot of attack vectors by default that don't exist. An important aspect of this MCP server is that unlike some of the things that are out there now, somebody created a really nice skill for an agent to use the Draw.io MCP server API. It's a wonderful thing to do, even with some Azure shapes on it, but it still has to call external. If you clone this and you run this inside of an organization, it is entirely self-contained. There are no external calls that this MCP server makes. So cut off all access from the outside, have it running in an organization where you might want to generate diagrams, you're concerned about privacy, have it run in a process perhaps that evaluate your Terraform or Bicep files or whatever it is to say, hey, based on these IAC templates that I have, can you create me a corresponding diagram so that I can have something that shows a little bit easier, a little bit better than, IAC types of files that are a little harder to understand without a visual context. So lots of options here. Have fun with it. If you don't mind, please go out and star and watch the repo. Fork it if you like. You're very welcome to submit issues for it, pull requests, whatever you would like to do. And yeah, thanks so much. Appreciate you.